Hello mathematicians! Today we are going to do completing the square. I'm going to show you a way that I was taught when I was at school, which I think is much easier than a lot of the sort of conceptual ways that are taught, particularly in Australia for some reason. Now, our aim is to take an expression like x squared plus 5x plus 6 and write it in the form x plus something squared plus something else. This is useful for sketching graphs. So the way we're going to do this, first we're going to look at the perfect square part of this. And we're just going to take some examples. X plus 2 squared. Now we know that this means x plus 2, x plus 2. We know that if we expand this, we get x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Now it's really important that you do a few examples of these. We'll do one more together. X minus 3, x minus 3, which gives me x squared minus 3x minus 3x plus 9, which gives me x squared minus 6x plus 9. And I'm going to write down a few more for you to try yourselves. Have a quick go at these. Pause the video, and this is what you should have. And I want you to draw your attention to just really the bits on the left and their resulting answers on the right. And what we should see, two things. Well, first of all of them just start with a single x squared, so we're not dealing with like 2x squared or anything like that. We'll talk about how we deal with those later. We can see that the x coefficient is always double the constant on the left. So for example, we have let's just do this in pink. We've got 2 here, doubles to give us 4. Negative 3 doubles to give us negative 6, 5 to 10, and so on. It's really important because that means that if we take an expression of the kind on the right, then we know that the expression of the kind on the left is going to have half of the x coefficient as its constant term. That's going to be easier to see it when we actually do it. And then the number at the end here is always the square of the number at the end of the bracket. So it's always the square of 2, negative 3, 5, 7, minus 1, and so on. Now here's how we're going to use that to complete the square quickly and easily. Suppose we are asked to complete the square for x squared plus 12x plus 20. Now I just want you to keep your attention on the x squared plus 12x. We know from all the experience we've had above, and hopefully it's not the first time you've seen all that stuff above, that this is going to be something to do with x plus 6 all squared, because we know that when we expand x plus 6 all squared, we're going to get x squared, we're going to get 12x, and we're also going to get a 36. And the 36 I don't want. I'm not looking at the 20 on that top line yet. I'm just thinking about making an expression which is the same as x squared plus 12x. So I'll just say that again. We know from experience that if we go x plus 6, that's going to give us the x squared plus 12x. It's going to give us a 36 that we don't want, so we take that away. And now we can just add the 20 on. Oops, wrong color. Plus 20. And that gives us x plus 6 squared minus 16. That's way quicker than a lot of ways you might be taught, which is supposed to be deep conceptual understanding or some nonsense. Let's look at a few mild variations. Minus 20x plus 1. Again, we're just looking at the x squared minus 20x. We know that it needs to be x minus 10 all squared. We know that if we expand that, we're going to get x squared minus 20x, and we're going to have 100 that we don't want. So we still take away that 100. So just follow the logic there. We're not saying that's a minus, so that's a plus. We're saying that when you expand x minus 10 squared, it gives you plus 100. That's not what I'm thinking about just now. I'm just looking at x squared minus 20x. So I take it away, and then I add the 1, which gives us x minus 10 squared minus 99. As I go through this video, I'm not going to say it every single time, but try pausing these yourself to try them out before I do them. In fact, let's make that minus 14. So try this one. We know we have x minus 7 squared. That gives us a 49 that we don't want. So we take it away, add the 20, and this gives us x minus 7 squared minus 29. Now, this can get slightly harder. Suppose we have, let's go 7x plus 1. So where we have an odd number. The key thing here, folks, is to just use fractions. So we go x, not 3.5, but 7 over 2 squared. Square of that is 49 over 4. That's the byproduct, which I don't want. Plus 1. Instead of plus 1, I can be a bit faster, a bit sneakier, and say, well, that's plus 4 on 4, because I know I'm going to then have to add that x plus 7 on 2 squared minus 45 on 4. Try that one. So we have minus 3 on 2 squared. Take away the byproduct, the 9 on 4. Add 5. 5 is 20 on 4, which gives us x minus 3 on 2 squared plus 11 on 4. And we can even do this if we have a fraction. I'll write this deliberately in a way that people don't like. Now, if we have x divided by 3, that is the same as a third of x. So if we take a third of x, or a third, and we halve it, that gives us 1 on 6 squared, minus 1 on 36, plus 5, that is going to be 5 times 36, 180 on 36, which simplifies to x plus 1 on 6 plus 179 over 36. There we go, super fast, super easy. What happens though if we have a non-monic quadratic, which is to say something like this? We have 2x squared plus 6x plus 10. Now, if this was an equation and it was equals 0, we could just divide everything by 2, but that's not what this is about. We need to keep that 2 in, so we're going to factorize it. 2x squared plus 3x plus 5. And now we're just kind of leaving the 2 and that big bracket out here, and we're working on the inside on this thing with no consideration of the 2 whatsoever. So that gives me x plus 3 on 2 squared minus 9 on 4 plus 20 on 4, which gives me 2x plus 3 on 2 squared plus 11 over 4. Now, this isn't quite finished. We need to expand this, and this expansion process is simple, but also a little bit sneaky. We're expanding the 2 over these two terms, over this one and this one. Okay, the expansion of brackets, we call it distributive across addition, which is a fancy way of saying it's the plus sign which separates the things that we're multiplying the 2 by. When we multiply the first lump, that bracket, by 2, we don't really do anything. We just say it's x plus 3 on 2 squared. 11 on 4 times 2. Hopefully we can do that without, we can see that if we're timesing this fraction by 2, we're really dividing the bottom by 2. So we go straight to 11 on 2. That's quicker than saying 22 on 4, which is 11 on 2. Okay. Try one of these yourself. Let's make 3x squared minus 9x plus 27. We go 3, big bracket, x squared minus 3x plus 9, which gives us 3. That's another 3 on 2, isn't it? Oh, x minus 3 on 2 squared. The byproduct is 9 on 4, so we take it away. Plus the 9, well, 9 is 36 divided by 4, which gives us 3x minus 3 on 2 squared plus 27 on... Do I mean on 4? I do mean on 4. I feel that's weird. No, that's okay. Sometimes the expansion work nicer than it has here, because now when we multiply this out, we get 3 times that first bracket, x minus 3 on 2 squared, 27 times 3, 2, 4, 6, 81 over 4. One for you to try. We factor out 2x squared plus 2x plus 4, which gives 2x plus 1 squared minus the 1 plus 4, which gives 2x plus 1 squared plus 3, which gives 2x plus 1 squared plus 6. Okay, final thing we need to consider is what happens if it doesn't factorize nicely. So what if we have 2x squared plus 5x plus 1? Well, the bad news is we just still factorize it. Well, if it's bad or good, we go x plus 5 on 2, sorry, x squared plus 5 on 2x plus 1 on 2. Now we can deal with fractions, so this shouldn't be a problem. Big brackets, we're working inside now. Half of 5 on 2 is 5 on 4. The byproduct is 25 on 16 plus a half. Well, I'm going to write plus 8 on 16, which gives me 2x plus 5 on 4 squared minus 17 on 16. Expand that, I get 2x plus 5 on 4 squared minus 17 on 8. And the other slight complication is if we have a negative, although this actually isn't particularly hard. If we have minus x squared plus 2x minus 3, we just factor out the negative 1. You can write negative 1 if you like, x squared minus 2x plus 3. And then that gives us minus x minus 1 squared minus 1 plus 3, which is minus x minus 1 squared plus 2, which gives it minus x minus 1 squared minus 2. I will write one for you to try, which combines those two, basically the same idea, isn't it? It's minus, come on pen, start working again. Sometimes it just likes to have a rest. Minus 3x squared plus 2x plus 6. Pause the video, try it out. We factorize negative 3, which gives us x squared minus 2/3 x minus 2. When you get to this point, it's a little bit hairy like this one, just double check. Minus 3 times x squared is minus 3x squared. Minus 3 times minus 2/3. Well, the 3's cancel, the negatives cancel, and I'm left with positive 2. And likewise, minus 3 times minus 2 is 6. Here, you might be tempted to say x minus 2 on 6, but hopefully we're confident to say that 2/3, I've got 2 kittens and I half it, well, that's really 1 kitten. The byproduct here is 1 on 9. If you wrote 2/6 here, by the way, it'll be fine. It'll just be uglier. Minus 2, so that's minus 18 over 9, which gives me minus 3x minus 1/3 squared minus 19 over 9, which when I expand gives me minus 3, just whatever it is, times the first bracket, and then the negatives cancel, giving me plus 19 over 3. Make sure you practice this with a bunch of questions, and hopefully it will see you completing the square super fast and super accurately.